For quiz 3, we were asked to compute the angular velocity of the rectangle triangle after the collision, as well as the velocity of point C on the triangle. In order to do this, several things needed to be recognized and computed. Here is a diagram of the two objects before the collision. The surface that the objects slide upon is considered frictionless. Here is a diagram showing the two objects at the point of their collision. It should be noted that the two objects stick together upon colliding. To start, the conservation of momentum needs to be applied to this collision. This simply relates the masses and initial velocity in order to solve for the velocity of the center of mass of the new compound. After this has been completed, the moments of inertia must be calculated for both the rectangle and the triangle. After this, the distances between each individual piece and the new center of gravity must be calculated in order to solve for the new compound's moment of inertia. This step is key. With this new distance, we use the parallel axis theorem to calculate the new moment of inertia. This relates the two individual moments of inertia with the new mass and distance to calculate the overall moment of inertia after the collision. Now, with the total moment of inertia found and the center of gravity, the conservation of angular momentum can be applied. Relating these two equations and taking into account the center of gravity, we can solve for omega. After calculating omega, the velocity at point C of the triangle can be obtained by simply plugging the parameters and solving for v.